Imagine a 5,000-ton freight train thundering across the countryside at 70 miles per hour. Underneath that massive wall of moving steel, the pressure is immense, enough to crush solid earth into powder. Yet if you look down at the tracks, you won't see advanced shock absorbers or high-tech carbon fiber foundations. You'll see rocks, millions of gray, jagged, seemingly ordinary stones stretched out for thousands of miles. Why do we entrust our multi-billion-dollar railway infrastructure to a loose pile of gravel? Why hasn't modern engineering replaced these stones with something more permanent? It's not about saving money, and it's certainly not for decoration. These stones, known as track ballast, are the only thing standing between a smooth journey and a catastrophic derailment. And the physics behind them is far more brilliant than you think. To understand why these rocks are there, we first have to understand the sheer violence of a passing train. A fully loaded locomotive exerts millions of pounds of force. If you simply bolted those steel rails directly onto the soil, the intense concentrated pressure would cause the tracks to sink and buckle instantly. This is the first and most critical job of the ballast: load distribution. Think of the track system as a sophisticated layer cake. At the top, you have the steel rails. Below them are the horizontal beams, called sleepers or ties. These sleepers sit directly on the ballast. When a train passes, the ballast takes that crushing weight and spreads it out over a much wider surface area. It dissipates the pressure so effectively that the ground underneath remains stable. Without this buffer, the earth would turn into a muddy grave for the railway within days. But there's a secret to these stones that most people miss. Have you ever noticed that you never see smooth, round river pebbles on a train track? There's a very specific engineering reason for that. If you tried to walk on a pile of marbles, you'd slip and slide everywhere. Smooth stones roll over each other. On a railway, that vibration would cause the stones to move away, and the tracks would slide apart. This is why engineers demand crushed stone, specifically granite or basalt. These rocks are chosen because they are incredibly hard, but more importantly, they are jagged and angular. When these sharp edges are packed together, they do something magical. They interlock. They bite into each other to create a solid, immovable mass that still retains a degree of flexibility. This locked state keeps the sleepers exactly where they need to be, preventing the tracks from shifting sideways even as a high-speed train screams around a curve. But wait, if the stones lock together so tightly, why not just use concrete? It seems more logical to bolt the tracks to a solid concrete slab, right? Well, that brings us to a fascinating paradox. The railway is actually a floating foundation. Unlike a building that is anchored deep into the bedrock, train tracks need to breathe. As a train passes, the ballast provides just enough flexibility to absorb the vibrations and slight movements. If the tracks were fixed to solid concrete, the rigid tension would eventually cause the steel rails to snap under the stress of heat expansion or seismic shifts. The ballast acts as a giant low-maintenance shock absorber that can be easily adjusted by a maintenance crew with a simple shovel and a tamping machine. However, the weight isn't the only enemy. The railway has two silent killers: water and weeds. If water accumulates under the tracks, it turns the foundation into mud, leading to pumping, a phenomenon where the sleepers bounce in a slurry of wet soil, eventually destroying the alignment. Ballast is the ultimate drainage system. It's effectively a giant French drain that spans the entire continent. Because of the gaps between the jagged stones, rainwater flows instantly through the ballast and away from the tracks, keeping the foundation dry and rock solid. And then there are the plants. In nature, life finds a way, but on a railway, a single tree root can ruin a decade of engineering. By laying down a thick, dense layer of sharp rocks, usually at least 15 centimeters thick, and up to half a meter for high-speed lines, engineers make it nearly impossible for vegetation to take root. No soil, no sun, no plants. This keeps the line clear and prevents biological decay from weakening the structural integrity of the sleepers. Before we conclude, there is one last surprising detail that connects modern high-speed rail to the age of sail. Have you ever wondered why we call these stones ballast? Centuries ago, when wooden sailing ships traveled empty to pick up cargo, they were dangerously light and would tip over in rough seas. Sailors would fill the ship's hold with heavy stones to weigh it down and provide stability. That weight was called ballast. When early railway engineers were looking for a way to stabilize their new iron horses, they looked at the discarded piles of ship stones at the ports and realized they were the perfect solution. They took the name and the concept from the sea to the land. So the next time you see those jagged gray rocks, remember, they aren't just a pile of gravel. They are a self-draining, weed-fighting, vibration-absorbing engineering masterpiece that has kept the world moving for over 200 years. If you found this breakdown of the hidden science around us fascinating, there's a lot more where that came from. Make sure to hit that subscribe button and turn on notifications. In our next video, we'll be exploring why airplane windows have that tiny, mysterious hole at the bottom. Trust me, your life depends on it. Comment below, what's another simple thing you want us to uncover the history of? Thanks for watching.